Good day and welcome in this probability lesson. No English sometimes. We'll be looking at mutually exclusive events, inclusive events, and exhaustive events, right? So mutually exclusive events, they in short can be seen as disjoint events, say two events that cannot happen at the same time, or a Venn diagram with no intersection, or no overlapping space, or no common examples. To give you a real life example, you can't be drinking a Coca-Cola and try to scream at the same time while trying to drink the Coke. You will choke on the Coke. Driving a car and cycling a bike. Either you drive the car or you cycle the bike, but you can't do both at the same time. So you have to be, that's mutually exclusive. If I have a diagram, so there we have prime numbers, there we have composite numbers. No? See those two circles have no intersecting space, they don't overlap. They have got 1, 2, 3, 4, 5 prime numbers. 1, 2, 3, 4, 5. I assume you know prime numbers, numbers that only has two factors, one in itself. Composite numbers have more than two factors. So my sample space here is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's what's in there. Right, so my number for my sample space, I have 2, 4, 6, 8, 10 values. No? So the number of elements in my sample space, 10. For prime numbers, I have 2, 3, 5, 7, 11, so there's 5. For composite, I have 4, 6, 8, 9, 10, so there is 5. So probability, I would get a prime number, right, equal 5 over 10 or 1 over 2. Right, probability, I have a composite number, 5 over 10, 1 and over half. Say probability, composite, and prime number, that is equal to 0, they don't match. So when the n part here is equal to 0, we say they are mutually exclusive. Right, so that changes the addition rule. So we found probability of composite or prime, it would equal probability composite plus probability prime, because C and P equal 0, so that part would fall away. So when the probability of two events with the n equals 0, we say it's mutually exclusive. Alright, inclusive events can be seen as events that have a joining point, right? So mutually exclusive, you are single and waiting for the right guy. Ne? Inclusive events, you met the right guy, and now you'll have some common elements and you'll decide you want to get married. Right, so two events that have common elements, right? Venn diagram where the circles overlap. Two or more events happening simultaneously. So they have soccer and rugby. They overlap there at 10, right? So that there is inclusive events. So my sample space here, if I say 14 plus 10 plus 18 plus 22, it gives me 64. Number that plays soccer, 14 plus 10, which gives me 24. Number that plays rugby, 10 plus 18, which gives me 28. Probability you play soccer, 14 plus 10, over my sample space, 24 over 64, simplifies to 3 over 8. Probability you play rugby, right? 18 plus 10, which gives me 28, over 64, which simplifies to 7 over 60. Probability you play soccer and rugby, so there where they overlap or intersect, that is 10 over 64, which become 5 over 32. So that value is not equal to 0, therefore this is inclusive events. Right? We do it via the addition rule, probability soccer or rugby equal probability soccer plus probability rugby minus probability soccer and rugby. So soccer 24 over 64, rugby 28 over 64 minus 10 over 64. 24 plus 28, 52 minus 10 gives me 42 over 64, and that becomes 21 over 32. So probability of soccer and rugby, if it was equal to 0, mutually exclusive. Not equal to 0, inclusive event. Right, I hope you understand the difference. Exhaustive events, these are events where the probability of two or more events add up to 1 or 100%. Short, it means they contain all elements in the sample space. So if I look here at example given on mutually exclusive events, the probability of A is given as 3 over 8. Probability of B is given as 5 over 8. Probability of A and B equal to 0. The fact that it's equal to 0 means it's mutually exclusive, right? So we say probability A or B, right, or P, A union B equal 3 over 8 plus 5 over 8, which gives me 5 plus 3, 8 over 8 equal 1. So therefore I have an exhaustive event that's mutually exclusive. If I look at inclusive events, probability A equal 4 over 7 given, probability B given as 5 over 7, probability A and B equal 2 over 7, right, given. So A or B would equal 4 over 7 plus 5 over 7 minus 2 over 7. 5 plus 4 gives me 9, minus 2 gives me 7 over 7, 1. Right, so there I have inclusive events that are exhaustive, meaning it's reached its maximum value. It's tired, it's exhaustive. Right, note complementary events are mutually exclusive and exhaustive. So that's just basic information for you. I hope you understand.